Welcome back to the second session of the probability. We're going to look at a number of examples and also enhance terminology on probability. We last said probability is just a guide. It does not tell us exactly what will happen. So that's very important to take note. If you want to get a recap of the whole session, please play back the recording afterwards. So let's proceed. We're going to use another example, and as we develop the examples in this topic, I want you to learn the terminologies. Terminologies, first of all, we are going to say and introduce what we call space. Okay? And then we're going to use the word sample space. In statistics, when we talk about space or sample space, we are actually talking about the total outcomes. You know the denominator in our probability. If I take you back to the formula, total number of outcomes, which is shown here, is what we're going to refer to as the sample space. That's what we're going to refer as the sample space. Total outcomes, total number of outcomes, that's going to be referred to as the sample space. You understand why this is very important as we continue the topic. In terms of the actual sample space of any question, it can be determined from the information given. So I want us to very quickly check something here, so that we're sure we're doing the right thing. Yes, certainly we are recording. The sample space, which is a total outcome, can be understood from the following question, which I'm going to call example 2, example 3, I think, yeah. Example 3. Okay. Let's take this example. I like working with examples, and I suppose all of you examples do help you to understand the actual principle in mathematics. In this example, we are going to say, let's go Mwanza. Wants to see how, you're still going to use the dice, how many times a double. So how many times a double, and I'll explain that to you, how many times a double comes up when throwing 2 dice at the same time. You hold 2 dice in your hand and you throw them twice at the same, once at the same time. How many times? A sample. So the question is, Mwanza wants to see how many times a double comes up when throwing 2 dice. And a double, it means, if you recall, yes, let's call dice 1, and it is dice 2. Okay, I just drew the same example, but in a different way. Same diagram, but in a different way. I want you to visualize. So each of this is dice 1, 1, 2, 3, 1, 2, 3, 4. Now let me we're drawing the 2 big. I want you to visualize this very, very well. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are the faces of dice, right? The 1, the 2, 3, 4, and we've got 5, and here there is 6. Okay, so he's here. Let me just distinguish them so that you can see clearly and use your imagination, right? These 2 dice are going to be thrown together. So this scenario is slightly different from the other examples which I gave you, where 1 dice was thrown and the chances of each of those numbers to come out was 1 out of 6, because 6 is the sample space, the total number of outcomes, the maximum. Okay, now this one is slightly different. I have these 2 dice and I want to throw them simultaneously. Now we want to find out the probability that when I throw them, it's going to be a double, which means in that throw I must have either 2, 2. You can either have 2, 2, or 3, 3, or 4, 4, or 5, 5, or 6, 6, or 1, 1. It's a double. So in other words, if I have this one here and I've got it's double, double. So what's the likelihood? There are chances that when I throw it, I can surely have this one coming out, or it could be this one coming out with that one, or that one coming out with that one, that one coming out with that one, that one coming out with that one, that one coming out with that one. That could be the outcome in my first throw. Or it could be that my first throw comes, it is that one coming out with that one, coming out with that one, or coming out with that one, 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 etc. Now if you do these combinations, you find that it's going to give you 36 ways as total outcomes. If you continue making these permutations, you discover that there will be 36 ways of outcomes. In mathematical sense, we can present them, the outcomes, as my first row could be a 1 and a 1. Yeah? Or it could be a 1 and a 2, etc. Yeah? Until I come to a place where it's a 6 and a 6. There's so many possibilities, and if I count all of these, 1, 2, 3, 4, 5, I'll end up 36 outcomes. 36 outcomes. 36 outcomes for the whole of this exercise. You understand that one? So, in order to determine this, we can now set up the experiment. Here's experiment. Here's experiment, where now you have your outcomes. This column experiment, I'll call it experiment. Here's the question, is it a double? Is the question, because I'm looking for a double. If I'm going to do this experiment faithfully until I find these answers, it will go on 36 times. My first row, because we don't know how it's going to come out, it could be a 3, 4. Is it a double? We said no. Again, we look through the experiment. Maybe it's a 5, 1. Is it a double? It's no. Through the permutations, peradventure at this point I get 2, 2. Is it a double? Yes. And so forth. I continue until I exhaust all the possibilities. Now the question we are asked is work out that probability that when I throw these 2 dice, the outcome will be a double, where we have 2, 2, or 3, 3, or 6, 6, or 4, 4, etc. Since it's an experiment, anything can come out, as you've seen in this column here. This is my experiment. You can do your own experiment, throw as many times as you can, keep recording until you get a double. So you may not get a double, but we have to work out the probability. So the number of ways this can give us, the number of ways this can give us is limited to the number of faces of the dice and the number of combinations. So we see that if I throw the first dice has got 6 as the total outcomes for a single number. That's dice 1. Dice 2 has also got a total of 6 for a single outcome. Okay? So sample space for our experiment is simply going to be 6 times 6, which is 36. Yeah? That's the sample space. Get a point? Has got 36. If you go back here, in this, what's the probability of having a double? 1, 2, 3, 4, 5, 6. There are 6 likelihoods. So you've got 1, 2, 3, 4, 5, 6. So 6 doubles can come out of this. So the possibility is 6 doubles. 2, 1, 2, 3, 4, 5, 6 chances. Okay? So there are 6 chances, or number of ways in which this can come. Number of ways out of the 36 possibilities. So a raw calculation would be, now, we know the sample space is 36, so possibly the probability in this one would be 6 out of 36, which you can simplify. Yeah. to further explain this, it's simple. So since Monza, right? Since Monza is looking for what? For a double. Remember, where both dice have the same number. This is where both dice have the same number. It's very important to note. Okay? It is made up of 6 points. It is what? It is made up of 6 points, of 6 sample points. Yeah, the sample space is 36. Out of this 6 is made up of 6 sample points. Very important to note. 6 sample points. Yeah. How does this look like graphically? The first row we are looking for should be 1, 1, or 2, 2, or 3, 3, or 4, 4. And continue to next page, or no, let me put this on the same page so that you can calculate properly. Let's just put it on the same page. I will repeat this for clarity. Let me see if I can fit the whole thing. So the points we're looking for is either 1, 1, 2, 2, 3, 3, these are the doubles, 4, 4, 5, 5, or 6, and the 6. How many points are these? This is the outcome Monza is looking for. 1, 1, which is 1, 2, 3, 4, 5, 6 sample points. These are the outcomes out of the whole sample space of 36. The denominator is 36 and the numerator is 6. So because there are only 6 possibilities, and if you simplify this, it always will show you 1 into 6 is 1. How many 6s are in 36? Is 6 times. So always simplify. Always do what? Simplify. So the probability we are looking for is 1 out of 6. This is ideal. Say after me, ideal. Yes, ideal. Because we are dealing with fair dice. Okay? Fair dice, which means the chances is well shaped, that's not, it's not biased. Yeah? Not what? It's not biased. It's not biased. You understand this as we progress in this topic. So with this kind of question, I beg your pardon, this kind of question, you look at the possibilities we are looking for. It is a double, and this is the way it can come out. And we know the sample space is 36. So in simple calculations, we set our standard. Expected result is 1 out of 6. Now, if you do an experiment, experiments don't always come out as ideal situations which are calculated. In the experiment that we have here, where I began listing the number of outcomes, counting them. The first row, no, it's not the right one. The second one, no, it's not the right one. It keeps throwing these things. It's not the right one. Oh yes, this one is the right one. It keeps on going. You can do this experiment 100 times. 100 times. Say for example, after doing it 100 times, out of this 100 times, he counts 19 as doubles. Right? Out of the 100 times, he counts 19 as doubles. What do you think the probability is? It will be the 19 outcomes out of the total 100 he is through. Now the situation is, I'll rush you very back quickly to this page. If this is the ideal calculation, right? If this is the ideal, right? And then in that experiment, he found that there were 19 doubles out of the 100 experimental data. Yeah? Experimental throws. Right? Which now becomes our sample space. So the probability here is simply 19 over 100. This is approximately 1 out of 5, isn't it? Yeah, this is 19. 19 here. Estimation 20. How many 20s and 100 is 5. Now, if you compare the 1 out of 5, is it closer to 1 out of 6? Ideally, if you look at that, it's pretty close, because an experiment almost matches the ideal data or ideal calculations. So in probability, this is how you will be able to work with a number of questions. Okay, let's also look at another example. Hopefully this can strengthen your learning as well. I'll move away from the dice and probably look at another one. Let's continue looking at further examples. This example is very interesting. It's now the question is, the following information, which is the whole of this table here. The following information is known about the classes at a school. This is year, class, girls, boys. So it's year 1, the type of classes, year 2, type of classes, year 3, type of classes, year 4, type of classes. So in this class P, under year 1, there's 7 girls, 9 boys, and so forth. You can see how the table is arranged. Now the question is, a class representative is chosen at random from each class. Which class, and this is the classes here, which class has the best chance of choosing a boy as their representative? So we are looking at which class has the chance, the highest chance of choosing a boy as the representative. So we're talking about probabilities. The first thing you have to do with this kind of data is simple and straightforward. Find the totals. That should be your sample space. Okay, that will be your sample space. What is the total number of the population of each class, boys and girls added together? We come to class P, year 1, and 9 plus 7, it is 16. And for class Q, it is 18. Class R, it is 17. Class S is 20. They've got 10 boys, 10 girls. Class T, it is 22. Class U, it is 23. And W, it's going to be 20. And X is going to be 23. That's what we have. So the question is, which of these classes has the highest chance that when they choose a representative, it's going to be a boy? So we're now going to get the ratio of the number of boys, or the fraction of the boys out of the total. So let's give it P boys, right? So how many boys are in P? It is 9 out of 16. Boys in Q is 18, is 10 out of 18. This one, the R, it is 9 out of 17. This one is 10 out of 20. The next class T, it is 12 out of 22. The next class is 13 out of 23. The next, it is 11 out of 20. The last one is 12 out of 23. You can convert this to decimals and see which one of these is the likelihood, or the highest, has the highest chance. So if you convert the probabilities as ratios, fractions, to decimals in this column, it will give you an idea. Convert the probability as a decimal. Yeah. If you do that, you find which number is the highest, and you can use your, remember the probability scale, it's always 1 here, it's always 0 here, in the middle it's half, and this is 0.5. So you're going to see the decimals which lie over here. This one is impossible. Remember the first lesson, this one is certain. If you put your findings on this scale, you can tell me which class. And I leave this as your homework. I want you to get the decimals in each of these. Put decimals there, convert this fraction into decimals, and tell me which of these decimal lies. Oops, have I lost? Did I lose the diagram? Yeah, which of those decimals lie either here in this region or in that region. And the answer will be the one which has a likelihood. The one that scores in this region is the one that has a higher likelihood to choose a boy as the class representative. At this point, I will end the session here.